In Lesson 14, we will be looking at summarizing a distribution using a box plot. So example 1 says a box plot, or a box and whisker plot, they can be referred to with either name, is a graph that is used to summarize a data distribution. What does the box plot tell us about the data distribution? How does the box plot indicate the variability of the data distribution? Here is a dot plot of the estimates of the times it took students in Mr. S's class to get to school one morning. So you'll notice it's a typical dot plot. We have 4 dots above 5, so that means it would take 4 students 5 minutes to get to school, and so on. Mr. S suggested that to be sure everyone had the same picture, statisticians developed a standard procedure for making the cut marks for the sections. So Mr. S wrote the following on the board, and this is how we are going to be finding the steps of making a box plot. So the first piece of this is to find the median of all of the data. So I have taken the step to list out all of the pieces of data for us. Couple of different ways you can do it. You can do the counting and dividing by 2 and figuring out which number it would be. Today I'm going to do the kind where we cross off 1 for 1. So 1 at the beginning for 1 at the end. And I'm going to do this until I get to the middle. So in this case, my median is going to be 15. Okay, so that is my median. I'm just going to write that right here for now. Now it's asking us to find Q1, which is the median of the bottom half of the data, and Q3, the median of the top half of the data. So what this is saying is, if your median is in your data set, like ours is right here, this separates my data into 2 halves. I'm going to find the median of the numbers to the left of the 15, and then I'm going to find the median of the data to the right of the median. The median does not get included when I do this. So I would start with 5 and 12. And this time I get 8. So now we call this Q1 right here. And then we're going to find Q3, or the median of the top half, in the same exact way. Again, that boxed in 15 does not get included in this, but the next one would. And we get Q3 of 25. Okay, so in order to make a box plot, you need something called a 5-number summary, and that includes these pieces of information. We've got a minimum number, which is just the smallest number in your set. So if we look up to the set, the smallest number here was a 5. It includes Q1, which remember is the median of that lower half of the data. So in this case, our Q1 was 8. It includes the median, which was 15. Q3, which is 25, the maximum or the greatest number in the set, which is 60. And then sometimes this right here is our 5-number summary, but sometimes you may be asked for the IQR also. Don't forget that your IQR is your Q3 minus your Q1. So we get the 17 for our IQR. Just an added piece of information that it doesn't actually go onto the box plot. So now we're going to draw a box plot for this information. The first thing that you're going to do is you're going to take the numbers from your 5-number summary, and you're going to put a dot above them. So notice we have a number line, and this number line includes my minimum and my maximum. It even goes up further, lower than my minimum and higher than my maximum. So what I'm going to do is I'm going to give some space in between my number line and my point, but right above the 5, I'm going to make a dot. Q1 is at 8, So right above, and I can even divide this if I want, 6, 7, 8, 9, and then just put a dot there if that helps you to split it. That's fine. Notice my dots are on the same level, so that's kind of important there. The next one is my median, which is at 15, which is on my number line. Then we have a Q3 of 25, which is also on the number line, and a maximum of 60. And you kind of, if you're making your own number line, it's a good idea to kind of work with numbers that will fit on your number line. Notice the 8 is in between two numbers, that's fine. But I couldn't count really in a better way to get numbers 5 from 60 on this number line. So if we go back up into the directions, we're going to draw a box that goes from Q1 to Q3, the middle two sections. So in order to do this, what I'm going to do is I'm going to draw a line that goes down through Q1, a line that goes down through Q3, and then I'm going to just finish the top and bottom of that box. I'm also going to draw a line that breaks down at the median as well. So this is where the box piece of box plot or box and whisker plot comes from. The whisker piece comes from drawing from Q1 out to the minimum and from Q3 out to the maximum. So those are the steps of actually creating a box plot. But the reason that we want to do this is to summarize the data. So if we're looking at this information, what this is it's separating the data into pieces, okay? So we've got the same number of numbers here, that we have here, that we have here, that we have here. So it's breaking it into 4 equal parts. So from the minimum to Q1, so from here to Q1, this is 1/4 of my data points. From Q1 to the median is 1/4 of my data. From the median to Q3, this is 1/4 of my data. And then from Q3 to the maximum is 1/4 of my data. Now you can also think of this in terms of percentages, because a lot of times it will ask about percentages. 1/4 is the same thing as 25%. If you think of it as 1/4, a quarter is 25 cents, 25%. So each one is 25% of your data. Now what is important here is that in each section, there's the same number of numbers. What the box plot shows us is how far spread out those numbers are. So if you notice, between the minimum and Q1, it's a tiny little line, whereas compared to between Q3 and the maximum, it's a lot longer of a line. That talks about the numbers within that section. So notice in each one, here I have 1, 2, 3, 4, 5, 6 numbers. I also have 1, 2, 3, 4, 5, 6 numbers here. So it's the same number of numbers or data pieces. It's, however, talking about how close in value they are to one another. So if we look, and I'm just going to erase the lines I drew so we can kind of look at those numbers a little bit better. I'm going to put Q3 back in there so we know where they separate. But those are the numbers we're looking at. So here in this first section, this tight little section here, the numbers are all really close together. I've got lots of 5s, a 7, and an 8. Those are numbers that are close together. If I go to where I have this longer piece, I can see the numbers are a little bit more spread out. I've got 25, 30, 30, 35, 45, and 60. Not as close as the 5s and the 7 and 8 are. So that's where the different length of the sections come from. So this right here, the numbers are much closer together, still fairly close together, a little bit further apart from each other, and then really spread apart. And if you look at the numbers, it kind of makes sense. So we've got the 5, 7, and 8, and here in the next section of numbers, which would be these, 10 and 12, pretty close together. And then in this section, we have 15s, 22s, all the way up to 25, which is a little bit further spread apart than what they were previously. And then in the last section is where we have that big spread. So this really can show us the variability of a data set. So we can think of this as a lot of the kids live a lot closer to school because 25% are within these tight little groups here, whereas as the number of minutes it takes for them to get to school gets larger, they're much more spread out. So if you see up in the dot plot, you can even see it there. Okay, and that's kind of what this breaks down to on the next page here. Each section is 1/4 of the data. Each section has the same number of data points, so that's that same 6 numbers in there. Smaller sections, the data is less spread out, the numbers are closer together, and it has less variability. Larger sections, the data is more spread out, the numbers are farther apart, and has greater variability. In our box plot for the data from Mr. S's class, it shows that the first half of the data is less spread out than the second half. So again, now they're talking about half of the data, so that's, remember this right here is where our median is, and the median splits the data in half. So it's showing that the first half of the data is much less spread out. Notice how it's a little tighter than what this would be, a little more spread out there. This would mean it took less time for most of the kids to get to school. Only a few students would have longer walks to school since the data is more spread out over the greater numbers. So just a little way to summarize data with that box plot. Okay, example number 2. Here it's asking us to find the 5-number summary in the IQR for the following data set and then create a box plot for the data. The IQR is not drawn as part of the box plot. So remember we said the IQR is just that extra set of data that we're just using here. So the first thing to remember is whenever you're working with a median, you need your data in numerical order. This set has already been set up for us like that, so we can work right off of it. So our minimum, remember, is our smallest number. In this case, that's 20. I always do my minimum and maximum first because they're the easiest to find. My maximum is 44. Okay, the next number that I always find is my median. So again, to find your median, 1 for 1, or split the data in half, however you want to do it. So 1, 2, 2, 3, 3, 4, 4. My median would be 35. Now this median is included in the set, so that means I'm going to work to either side. One thing I do want to point out at this point is if there was another number, so I'm just going to kind of do 1, 2, 3, 4, 5, 6. So let's say we did this. To find our median would have to be in between 3 and 4. So what happens there is when you have a median that's in between two numbers, the 3 goes to this side and the 4 goes to that side when you go to start looking for Q1 and Q3. So again, the split line, if it's in between two numbers, that's what separates the data. Whereas here, that median is going to separate the data, and we don't include it when we start looking for Q1 and Q3. So here, I'm going to find the median of the left side of 35 and then the median of the right side. So again, just going backwards, we have 2 in the center. That means in between 21 and 25. So I would add 21 and 25 together and then take those 2 and divide it by 2 and get Q1 of 23. Okay, so that's our Q1. On the other side, I am going to do the same process. I've got 2 in the center, 40 and 42. Now, I can look at this and see directly in the center of 40 and 42 is 41, but you could, however, do the same process, add 40 plus 42, and then divide by 2. So Q1 is 23, and Q3 is 41. To find the IQR, remember you do Q3 minus Q1, which is 18. Okay, so we're not going to be putting that IQR into our box plot, but we do need to put the other numbers. So we're going to start with the minimum above 20. I'm going to put a dot above 23, and if it helps for you to break it down, so 21, 22, 23, 24, you can make those lines. That may help you to distinguish where it is. 35 is the next number, 41, again, if it helps. do that, and then at 44. Okay, so there's the dots for my numbers. I'm going to take the middle 3 dots to make the box. So draw down through each of those dots, connect across the top and across the bottom. And then draw out your whiskers to those other numbers. So again, what this data is showing us here is that in here, they're very close together, the numbers. And if you look at those numbers, we've got 20 and 21, super close. The next ones are 25 and 31, a little bit more spread out compared to 20 and 21. The next ones are 38 and 40, again a little closer together, and then 42 and 44, again fairly close together.